We know a chemical formula tells us the ratio of elements in a compound. In this video, we'll look at how the chemical formula of a compound is determined from an experiment. We will also look at the amounts of compounds that react or compounds that are produced in a chemical reaction. In each case, we have to do mole to mass conversions. When I was your age, stores used to have this game, guess how many pennies are in the jar. Stop the video and figure out how you would do that. The answer is to measure the mass of all the pennies, measure the mass of one penny, and then divide the total mass by the mass of one penny. Here is our conversion factor. This is the idea of counting by weighing. Sodium is related to high blood pressure, so many people have to watch how much salt they eat. So if I sprinkled 1 teaspoon or 6 grams of salt on my sandwich, how much sodium am I eating? We would do these conversions. The mole is like the chemist's dozen. 1 mole of a substance is this huge number. So just like with the pennies, if we know the total mass of salt and the mass of 1 mole of salt, we can calculate the moles of salt. This is our conversion factor, but how do we figure out the mass of 1 mole of salt? So if we know the mass of any substance, how do we calculate the moles of that substance? What is the conversion factor in each case? The conversion factor is the molar mass of that substance. Molar mass is defined as the mass of 1 mole of that substance. The molar mass of a substance is determined from the chemical formula of that substance and the atomic weight of the elements in that compound. So if we know the mass of a substance and its molar mass, we can rearrange this equation and solve for moles. Remember these formulas. From the periodic table, the molar mass of hydrogen is 1 gram per mole, molar mass of oxygen is 16 grams per mole, for water it's 18 grams per mole. So if you measure 2 grams of H, that means you have 2 moles of H, or 2 times 6.02 times 10 to the 23rd atoms of H. So that means 16 grams of O contains 1 mole of O. And if you measure 18 grams of water, that 18 grams contains 1 mole of water, or 6.02 times 10 to the 23rd water molecules. Speaking of water, we're about 60% water, and we consume about 2 million gallons of water each year. Your water footprint consists of not only the water you use when you take a shower or brush your teeth, but in the 125 liters of water to make 1 apple. Let's practice doing conversion. Stop the video and answer this question. And the answer is 1 drop of water is 0.05 mils, so we want to convert from mils to grams using the density of water as our conversion factor. Next, we want to convert from grams to moles using molar mass as our conversion factor. Finally, we'll convert moles of water to moles of H using the chemical formula of water. Stop the video for a second and answer this question. Is the moles of O the same as the moles of H? The answer is no. Let's go back to salt. The recommended daily amount of sodium per day is 2,300 milligrams. Stop the video and answer this question. Here is the answer. First, convert from milligrams of sodium to moles of sodium. Then from moles of sodium to moles of NaCl. And finally from moles of NaCl to grams of NaCl. 5.8 grams of NaCl is about 1 teaspoon of salt. Note the molar mass conversions here and chemical formula conversion there. Sulfuric acid is the most produced chemical in this country. We know this chemical as the acid in car batteries, but its main use is in the manufacture of fertilizers. The chemical formula of a compound is determined by doing an elemental analysis experiment. This experiment tells us the percent composition of that compound. So stop the video and try these 2 problems. And the answers are: the chemical formula of water tells us there's 2 moles of H and 1 mole of O. So let's convert from moles to grams. The percent hydrogen is calculated using this formula. Note that the total mass is the molar mass of water. So water consists of 11% hydrogen and 89% oxygen. In an elemental analysis experiment, you have the percent hydrogen and percent oxygen. 11% hydrogen means 11 grams of hydrogen, so convert that to moles. 89% oxygen means 89 grams of oxygen, convert that to moles. The subscripts on our chemical formula tells us the mole ratio of each element in that compound, but what's wrong with this formula? Well, the subscript should be a whole number, so here's what we should do. Divide by the smallest number, and that'll give us the formula for water. Elemental analysis of a hydrogen oxide compound shows this percent composition. Stop the video and answer these two questions. And the answers are no, because that percent composition doesn't match the percent composition for water. And the chemical formula for this compound is, turns out that there's not an H1O1 compound, but there's an H2O2 compound, which is hydrogen peroxide. Let's do another practice problem. Stop the video and determine the chemical formula of this compound. And the answer is, in this problem, we're given the percent composition and the molar mass. So stop the video and determine the chemical formula of ethylene glycol. And the answer is, the chemical formula is CH3O based on the percent composition. The molar mass is, this molar mass is half the molar mass of ethylene glycol. But if we multiply the subscripts by 2, the molar mass of that formula equals 62 grams per mole. So this is the formula of ethylene glycol. So this is the simplest chemical formula of this compound. That's called the empirical formula, but note that it doesn't match the actual chemical formula of ethylene glycol. Let's do another application of percent composition. So hemoglobin has a molecular weight of 64,500. There's only 0.35% iron. Stop the video and answer this question. And the answer is, so there are 4 iron atoms in one hemoglobin molecule. To review, we're not going to count individual atoms and molecules because they're too small and there's too many of them. But just like the pennies in the jar, we can count the number of atoms and molecules by weighing them. The conversion factor going from mass to moles or moles to mass is going to be molar mass. So in this video, we went from percent composition to the chemical formula of a compound. In the next video, we're going to do these conversions to predict how much reactants react and products are produced.